Have you ever wondered if traveling faster than light could be a reality and not just a science fiction concept? The idea of faster-than-light travel has long been a beloved staple of science fiction, capturing our collective imagination and fueling countless narratives. Perhaps the most iconic of these is Star Trek, with its advanced starships zipping across galaxies at warp speed, defying the boundaries of space and time. But what does it mean to travel faster than light? In the realm of physics, light speed is the ultimate cosmic speed limit, clocking in at roughly 186,000 miles per second. It's so fast, in fact, that a beam of light could circle the Earth 7.5 times in the blink of an eye. This limitation was famously posited by Albert Einstein in his theory of relativity. According to Einstein, as an object accelerates towards light speed, its energy increases and so does its mass. The closer you get to the speed of light, the more energy you need to accelerate further. Eventually you would need infinite energy to reach light speed itself, making it an impossible barrier to cross. It's a paradox that has puzzled scientists and dreamers alike. If nothing can move faster than light, then how can we ever hope to explore the farthest reaches of the universe? How can we make the fantastical journeys of science fiction a reality, traversing vast cosmic distances in the blink of an eye? The answer might lie in a surprising place, not in breaking the laws of physics but in bending them. A concept known as the Alcubierre drive, named after the physicist Miguel Alcubierre, proposes a method of faster-than-light travel that doesn't violate Einstein's theory of relativity. So if Einstein is right and nothing can travel faster than light, how could warp drive ever be possible? Well, the answer to that question takes us on a journey through some of the most fascinating corners of theoretical physics. Stay tuned as we delve deeper into the mysteries of warp drive and faster-than-light travel. Scene script. Enter the concept of warp drive, a theoretical propulsion system that could make faster-than-light travel possible. Imagine gazing at the stars, knowing that you have the ability to traverse the vast cosmic distances in a fraction of the time it currently takes us. This isn't just a plot device in a science fiction novel, it's the intriguing premise behind the concept of warp drive. So, what exactly is warp drive? Well, it's a theoretical propulsion system that doesn't rely on conventional means of travel. Instead of propelling a spacecraft through space, warp drive works by distorting the fabric of space-time itself. To understand this, let's first acknowledge that space-time is a four-dimensional fabric that makes up our universe. It's not just something static, it bends and curves in response to mass and energy. This is the foundation of Einstein's theory of general relativity. Now, what if we could manipulate this fabric to our advantage? That's where warp drive comes in. The idea is to create a bubble of space-time around a spacecraft. Within this bubble, the ship would remain stationary. However, the space-time in front of the ship would contract, while the space-time behind it would expand. In essence, the ship isn't moving, it's the space-time around it that's doing all the work. It's a bit like surfing a wave, where the surfer is stationary relative to the wave, but moving relative to the shore. This manipulation of space-time would allow the spacecraft to move at effective speeds faster than light, without breaking any of the laws of physics. The ship and everything inside it would be at rest relative to its local space-time, so no time dilation or other relativistic effects would occur. Of course, this is all theoretical and hinges on our ability to distort space-time in such a manner, which is currently beyond our technological capabilities. But the concept itself is fascinating and holds immense potential for the future of space travel. This concept of warping space-time brings us to an essential element of warp drive technology, the Alcubierre metric. The Alcubierre metric, named after physicist Miguel Alcubierre, is the mathematical model that describes how warp drive could work. Let's break this down in simple terms. Imagine space-time as a fabric. Now picture a ship sitting on this fabric. The ship isn't moving, but what if we could make the fabric itself move? That's the basic idea behind the Alcubierre metric. To get a clearer picture, think of it like a magic carpet ride. The ship is on a carpet, or a bubble of flat space-time. This bubble is what's moving, not the ship itself. The bubble contracts space-time in front of the ship and expands it behind, creating a wave of space-time that carries the ship along. It's like surfing, but instead of riding on a water wave, the ship is riding on a wave of space-time. The beauty of this concept is that since the ship is stationary inside the bubble, it doesn't experience any time dilation. This means that the crew doesn't age faster or slower relative to people outside the bubble. Now here's where it gets interesting. The speed of the bubble isn't limited by the speed of light. So, theoretically, the ship inside the bubble could travel faster than light. In other words, the ship could reach distant stars in a fraction of the time it would take light to make the same journey. But there's a catch. The energy required to create this warp bubble is immense. Some estimates suggest we'd need the energy equivalent to the mass of Jupiter, and that's just to create a bubble big enough for a small ship. Furthermore, the bubble requires something called exotic matter to keep it stable. Exotic matter is a theoretical form of matter that has negative energy density, and right now we don't have any concrete evidence that such matter even exists. But, as we will see, creating this warp bubble is easier said than done. Achieving warp drive technology is fraught with theoretical and practical challenges. Warp speed, as we've come to know it from our favorite science fiction narratives, involves bending the fabric of space-time itself. This is not a simple task, to say the least. One of the primary hurdles we encounter in this endeavor is the need for exotic matter with negative energy density. This peculiar form of matter is what's theorized to create the warp bubble, a crucial component for faster-than-light travel. But here's the catch: we've yet to discover or create this exotic matter. Our current understanding of physics doesn't quite allow for its existence. Beyond the theoretical, there are practical challenges too. Even if we were to harness the power of warp drive, how would we control and navigate such an immensely powerful technology? Imagine having the power to distort the very fabric of reality at your fingertips. The implications are enormous, and frankly a bit terrifying. Then there are the environmental and ethical considerations. If we're warping space-time, what impact could that have on the surrounding cosmic environment? Could we inadvertently create black holes or disrupt the gravitational balance of nearby celestial bodies? And let's not forget the potential for misuse of such a technology. Warp drive could open up new avenues for exploration and discovery, but it could also be weaponized in unimaginable ways. But don't let these challenges dampen your enthusiasm. They are not insurmountable. They're simply puzzles waiting to be solved. And that's what science is all about, isn't it? Pushing the boundaries, questioning the status quo, and daring to dream of the seemingly impossible. Despite these challenges, research into warp drive continues, with some fascinating developments. So buckle up, because the journey to warp speed is going to be one heck of a ride. As we delve deeper into the cosmos, there's no telling what we'll discover or what new challenges we'll encounter. But one thing's for sure, the quest for warp drive technology is far from over. So where does this leave us in the pursuit of faster-than-light travel? Well, let's take a look at the present and future of warp drive technology. Currently, research into warp drive is still in its infancy. It's a concept deeply rooted in theoretical physics, and we're just beginning to scratch the surface. NASA, the world-renowned space agency, has shown interest in this concept. They've been exploring advanced propulsion concepts, including warp drive, under their Breakthrough Propulsion Physics project. This project aims to investigate and develop revolutionary propulsion methods that could potentially transform our approach to space exploration. While warp drive remains a theoretical concept within this project, the research and investigation being carried out could lead to other groundbreaking discoveries. The future of warp drive, though uncertain, is intriguing. The technology, if realized, would revolutionize space travel, allowing us to traverse vast cosmic distances in a blink of an eye. This could open a new era of space exploration, where interstellar travel becomes a reality, and we could visit distant galaxies that are currently unreachable with our existing technology. However, it's important to remember that warp drive, as exciting as it may sound, is still largely theoretical. There are numerous challenges to overcome, from the creation of exotic matter to the control of enormous amounts of energy. It's a concept that pushes the limits of our current understanding of physics and requires technological advancements that are currently beyond our reach. But here's the thing, even if we don't achieve warp drive, the journey towards it is beneficial. The research into warp drive forces us to challenge our understanding of the universe, to think outside the box, and to innovate. It encourages us to push the boundaries of science, and it's this kind of thinking that leads to breakthroughs. Whether or not warp drive will ever become a reality, the journey towards it is pushing the boundaries of our understanding of the universe.